All right, guys. So last 2 days we had, because I wasn't here, but we did have the videos like y'all were watching through, going through the notes. So I'm going to go back through these kind of today, just rehash, kind of re-go back over it if there's any questions. Because we had this one here, solving 4-5, solving polynomial functions. And we went through the kind of just the four main ways that we know how to solve up to this point. Factor, graphing, quadratic formula, and completing the square. Factoring, graphing, quadratic formula, and completing the square. These are the main ones that we had. We'll put that away for now. So now with all these here, these two here only work if it is a quadratic. It's a degree 2. So the biggest exponent attached to the variable has to be 2. And that's the only way those two work. Factoring does work. We didn't have time to get too involved into factoring these higher degrees, but we will come back to it. We will do more of that later. And graphing works on any of them. So really, we're going to use graphing and some different methods to get the degree down to a degree 2. Because if we can get it down to a degree 2, then we can use the quadratic formula or completing the square to solve from there, or our square root method, some of these other methods to solve the rest of it there. Now, we did go through some of these here with factoring and those there, but I'm not going to focus too much on that today. The video did go through those there. Because when we look at this one here, negative 2x to the fourth plus 16x squared minus 32. And I believe in the video we did factor this, but I'm going to go on and graph it to start with, because graphing is most likely going to be the place that y'all start with these. And with any of these here, if we're graphing, finding the zeros, finding the solutions, we need to get it equal to 0 and get all the variables on the same side of the equal sign. So we'll start with negative 2x to the fourth. We'll need to clear all that out. Negative 2x to the fourth plus 16x squared minus 32. And we can graph it to try to find the zeros, the places where it equals 0, where our solutions are. And this one here did give us 2. Incidentally, they are negative 2 and 2. Those are 2 of our solutions. And as I talked in the video in these here, we can use division, or synthetic division, long division, to actually find the others. Because according to the remainder theorem, whatever the remainder is when we do synthetic division is the solution or the value of the function if we plugged it in. So here, if we do synthetic division with 2, and we plug in our values across the top, so negative 2 for x to the fourth, 0 for x cubed, 16 for x squared, 0 for x, and negative 32, we should expect the remainder to be 0. Because it is a solution, when we plug it into the function, the value should be 0. Because when we solve, we're looking for values of x that will make the function be 0. So if we do the synthetic division here, bring down the negative 2. Well, 2 times negative 2 is negative 4. Then we add straight down. 0 plus negative 4 is negative 4. 2 times negative 4 is negative 8. 16 plus negative 8 is 8. 2 times 8 is 16. 0 plus 16 is 16. And again, we multiply our 2 times 16, which is 32. And negative 32 plus 32 is indeed 0. So what that's telling us is that negative, or 2, is one of our solutions. We also know that negative 2 is a solution. So we can do the synthetic division again. Now we don't have to rewrite negative 2, negative 4, reset the whole thing up below it, because we can just put the cubby and do it again and see what we get for the remainder. Because negative 2 times negative 2 is positive 4. Negative 4 plus 4 is 0. Negative 2 times 0 is 0. 8 plus 0 is 8. Negative 2 times 8 is negative 16. And 16 plus negative 16 is indeed 0. So we had 2 solutions. We did synthetic division twice, and we got 0 twice. So it has confirmed that those are the solutions. But we didn't have any others. So let's put the variables back in and see what the equation we have. Now our 0 is our remainder. The 8's the term without a variable. Our 0 is our term with x. Negative 2 is our term with x squared. So it tells us our final equation right now is negative 2x squared plus 8. And again, we're still solving this. We're trying to see where this is equal to 0. Now, since we do have just the x squared, we can do the square root method, or we can try graphing. If we did the square root method, and it only works if there is not an x to the first power, we just have x squared. We can first subtract 8. We need to get the x squared by itself. And if we subtract 8 from both sides, it tells us that negative 2x squared is equal to negative 8. At this point here, we can divide both sides by negative 2. It tells us that x squared is equal to 4. And last but not least, we can take the square root of both sides. And the square root of x squared is x. Square root of 4 is 2. But whenever we take the square root of both sides, we have to add the plus or minus. So it's telling us 2 of our other solutions are 2 and negative 2. Which really means our solutions are negative 2, 2, negative 2, and 2. We actually have 2 and negative 2 twice. And those are the 4 solutions for this here. Yeah. So questions on this here. So maybe that makes more sense. If something doesn't make sense, even though we're seeing it again, please ask. Now, this did show up on the graphing calculator. Because if we look at the graph, anytime the graph touches the x-axis but does not cross, it has an even multiplicity. There's an even number of zeros there. That's why at negative 2 and 2, it touches the graph but does not cross, because the number of zeros at both places, 2, it shows up twice. So x to the 4th minus 18 x squared plus 81. So if we look at the second one, x to the 4th minus 18 x squared plus 81. If we graph this here, we get a similar thing, but this time it's coming from the top instead of the bottom. If we look at the table, it tells us one of the solutions where x gives us a y value of 0 is a negative 3, and the other one is at 3. So this is telling us already that our solution is x is equal to 3 and negative 3. Questions on what we've done so far? Because really the graphing calculator is giving us a lot of these answers. Now for this one here, there's going to be 4 solutions, and we'll get into and get the full explanation on Monday of why this is or how we can be able to tell from it. And it's all revolving around the fundamental theorem of algebra. Now here the first thing I'm going to check is the 3. Because again, part of the reason we're doing this is removing solutions, removing possible answer choices. Because the degree for this is 4. And each time we do synthetic division, we decrease the degree by 1. So if I do this once, it'll take it to a degree 3. We do it again, it's going to take it to a degree 2. If we had a third solution, we could take it from a degree 2 down to a degree 1. And that's the easiest one to solve. Because here with 3, we multiply through. 3 times 1 is, well, 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 18 plus 9 is negative 9. 3 times negative 9 is negative 27. 0 plus negative 27 is, well, negative 27. 3 times negative 27 is, well, negative 81, which does indeed give us a remainder of 0. And we expected that because, again, the graphing calculator told us it's a solution. It told us that value is 0. So the remainder has to be 0. Now, we did mention the fact that it touched at that 3 and went back up, yes? So there's a good chance that that 3 is not only a solution once, but could possibly be a solution twice. And the way I can check that is, again, I can plug that 3 in and try this again, because our 3 times 1 is 3. 3 plus 3 is 6. 3 times 6 is 18. Negative 9 plus 18 is 9. 3 times 9 is positive 27. And negative 27 plus 27 is indeed 0. So we are able to see that 3 does show up twice. So we can add that to our solution set. So we've taken it from a degree 4 to a degree 3. Did it again, took it from a degree 3 to a degree 2. Now, we do have another solution. We have our negative 3. So let's do the synthetic division with it there to bring it from a degree 2 to a degree 1. Negative 3 times 1 is negative 3. 6 plus negative 3 is 3. Negative 3 times 3 is negative 9. And 9 plus negative 9 is 0. Yes? Okay. Well, if I plug the variables back in at this point, remainder, 3 is our term without x, 1 is our term with x. So what it tells us our final equation is x plus 3 is equal to 0. And to solve this here, we would subtract 3, telling us x is equal to negative 3. So really the goal with graphing, when we graph these here, is we want to get at least 2 less than the degree number of solutions. Because here with this degree 4, if I can get at least 2, we can get it down to a quadratic formula solve. Or if it gives me 4 or 3, we're good, because when we use the synthetic division, we decrease the degree by 2, by 1 each time we put 1 in, and it makes it easier to solve. Questions on this here? Okay. Now the rational root theorem. Okay. Now I was getting this mixed up with the irrational root theorem. Rational root theorem. If we have a polynomial of degree n, that's all this thing is saying. If we have a polynomial with integer coefficients, numbers in front, then every rational solution, every solution that can be written as a fraction or in a whole number, an integer, a positive, negative number. We're not talking about our square roots, our cube roots, our radicals, or our imaginary numbers, can be given to us by this formula here, our plus or minus p over q. where P is the factors of the constant term, our term without a variable, and Q is the factors of the leading coefficient. So, very good. So, let's look at how this works here. Because if we want to find all the solutions, so we're going to look at all the rational zeros for this here, are plus or minus P over Q, and then we're going to go to factoring. So P is the factors of our constant term. And our constant term, our number is what? 20. It's the number without a variable. So one of the sets of factors for 20 are, well, 1 and 20. We also know that 2 goes into 20, when that would be 2 and 10. 3 doesn't work, but 4 and 5. So all the factors of 20 are 1 and 2, 4, 5, 10, and 20. Those are all the factors of 20. Because our two numbers are pairs that multiply together to give us 20. Q is the factors of the leading coefficient. Leading coefficient is the number in front of the variable with the biggest exponent. And here it is 1, because 1x cubed. 1 is our leading coefficient. Okay. Now the rational zeros is plus or minus P over Q. And the way I go through this and do this is I start with the first value of Q and divide each value of P by it. So we would indeed start with 1 divided by 1, which is 1. And then 2 divided by 1, plus or minus 2. 4.
Okay, so it's just 1, 2,
4, 5, 10, and 20. And with this rational zeros, we will always get the factors of P back with the plus or minus because we have to divide it by 1. Now, if there was another value for Q, if it was, say, 2, we would do the exact same thing. We do 1 divided by 2, 2 divided by 2, 3 divided by 2, 4 divided by 2, go through with 2. And simplify if necessary. If any of them are repeated, as 2 divided by 2 is 1, we already have 1 listed. We're not writing it twice. So questions on this here so far? Okay. Now, as I went through this, and especially in the video, pure math, or mathematically, the pure math way we would do this is, well, I have all these possible rational zeros, yes? So they are possible solutions, and we can take our polynomial equation and use synthetic division with it. I would watch this one here, because we would start with, say, positive 1. And we'd say, not 11, 1. 1 times 1 is 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 11, or 11 plus negative 7 is 4. 1 times 4 is, and 20 plus 4 is 24. So we get a remainder of 24, yes? Does that mean 1 is a solution? Well, no, because if it's a solution, it's the value of x that makes the function equal 0. So if it is a solution, the remainder should also be 0. So, okay, so that means it's not 1. All right, so we can erase all this here. And then we would, okay, so 1's out, because if it doesn't work on one of the synthetic divisions, it's not going to work on any of the following. Then we'd go negative 1 and do the same thing. Negative 1 times 1 is negative 1. Negative 8 plus negative 1 is negative 9.
I think it just been negative.
Yeah. Negative 1 times negative 9 is 9. 11 plus 9 is 20. Negative 1 times 20 is negative 20.
Nice.
And negative 20 plus 20 gives us 0. So, negative 1 is the first solution that we have. Well, yes. It could be that -1 works twice, so then we can try -1 again. If it works, we have another 0. If it doesn't, then we move on to 2 and see if it works. If it works, awesome, we have another solution. If not, we move on to -2, 5, -5, 10, -10.
Could like number 1, could we like retry the normal 1 again, now that we're on the lower half?
We could, but incidentally, if it doesn't work at one of them, it's not going to work on, yeah.
If it changes.
Luckily enough, if it didn't work, since it didn't work there, it actually won't work here. And sometimes it's easier to see because 1 times 1 is 1. -8, -8, 12. So, and we could try -1 and go through this here. But always a good place I would start is the calculator. Because we can get those there, and then I can look at this here. And if we said x to the third minus 8x squared plus 11x plus 20, we graph this. So the graphing calculator does tell us that -1 is the solution, yes? But it also tells us 4 and 5 are solutions. Well, we do have positive 4 and 5. Yeah, so if we did 4 times 1 is 4. -9 plus 4 is -5. -5 times 4 is -20, which does give us a remainder of 0. Yes? So that tells us x is equal to -1, 4, and we also had 5. Because at this point here, it's saying that x minus 5 is equal to 0. We add 5, telling us x is equal to 5. Questions on this here? Do we kind of see how this works? Yes? Okay. Now the question also is, well, why would we even mess with the rational zeros if the calculator essentially gives us all the answers? Yes? So again, I'm jumping ahead to this one here because we did some of these, we had a lot of this already covered. I'm mainly just wanting to recap some of the stuff, key points. Finding the zeros of this here. We want to find all the zeros. Well, most likely, we would go straight to, all right guys, let's focus in. X to the third. Minus 42 x squared plus 7x plus 12. Most likely the first place y'all are going to go is to graph it. Yes? And we get this here. Second table. Oh. 10x to the fourth minus 11x cubed minus 42x squared plus 7x plus 12. And if we look at this graph, we see that it does cross the x-axis at 4 places, yes? And it's all going to be close to 0. Because if we look at the hash marks, they are going by 1, so -1, -2, they should one should be there. And we should also have 2 before 4 on the positive side. And if I look at the table, well, between -4 and 6, I don't have any zeros. I don't have anywhere y is 0. I don't have any solutions there. So this is one of the places where having the rational zeros, this p and q, or plus or minus p over q, is helpful in finding these solutions. Because we can possibly factor it and go about that way. It's not going to be as easy to find the factors, because there are. But let's look at the factors of p and q first. P, constant term, the term without a variable. So we're looking at the factors of 12, which would be 1 and 12. 2 and 6, 3 and 4. Those are all the factors of 12. 3, 4, 6, 12. Factors of Q, factors of the leading coefficient, the number in front of the variable with the biggest exponent, which would be 10. We'd have 1 and 10, 2 and 5. Plus or minus P over Q. So we'd start off with dividing all the values of P by 1. So we'd have, really, we're just relisting all the factors of P with the plus or minus. So we just divide 1, 2, 3, 4, 6, 12 by 1. Which just gives us plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And once I finish with that, I move on to 2. So we're going to do 1 divided by 2, which is plus or minus 1/2. It doesn't reduce. Our next one would be 2 divided by 2. Well, that does reduce. 2 divided by 2 is 1. Is it listed? Well, yeah, we already have 1 listed, so we're not going to list it again. Move on to 3 divided by 2. Well, that doesn't reduce. It's not listed. So we have plus or minus 3/2. 3 divided by 2. Then we can move on to 4 divided by 2. Well, 4 divided by 2 is 2. It's already there. We don't list it again. Then we move on to 6 divided by 2, which is 3. Already there. 12 divided by 2 is already there. So it just added 2. Now we move on to 5. Well, 1 divided by 5. 1/5, which isn't listed, so we have it there. 2 divided by 5 is 2/5. It's already there. 3 divided by 5 would be plus or minus 3/5. 4 divided by 5 would give us plus or minus 4/5. 6 divided by 5 would give us plus or minus 6/5. And 12 divided by 5 would be plus or minus 12/5. We get all these here. Then lastly, we can move on to 10. 1 divided by 10 would give us plus or minus 1/10. The 1's always going to have a factor, or have a P or Q, rational P over Q, because it's not going to reduce. It's 1 in the number. 2 over 10 will reduce to 1/5, which we already have. 3 over 10 doesn't reduce, so we get plus or minus 3/10. 4 over 10 reduces to 2/5. 6 over 10 reduces to 3/5. And 10 over 12 reduces to 6/5. And again, if you're not sure what those are, the 30xs will do it. We can just do 1 over 10. It'll tell us it's 1/10. 2 over 10, it'll tell us it's 1/5. It will reduce those fractions for us. We don't have to do all those by hand. Okay? Questions on this so far? Now, it told us that it's 1, 2, 3, 4, 6, 12, yes? We already have it in the graphing calculator. 1, 2, 3, 4, 6. Are any of those 0? Let's look at 12. Keeps getting bigger. Is 12 0? No. Okay, let's look at the negatives. -1, -2, -3, -4, -6, -12. None of those numbers gave us a y value of 0, yes? So what that means for us is if we looked at this whole list, because if we did it the other way, well, I'd have to try 1, -1, 2, -2, 3, -3, 4, try all those values and see if it gave us a y value of 0. But since the graphing calculator, we looked at it and none of these had a y value of 0, well, I know that none of those are going to be a solution. We're solving for it. We're trying to find the value of y that'll make the function equal 0, yes? 1, 2, 3, 4, 5, that's 12, or 6, 12 values. I don't even have to check because the graphing calculator told me it wasn't 0, they're gone. So now I'm left with these here. 1/5, negative, or 1/5, 2/5, 3/5, 4/5, 6/5, 12/5, 1/10, 3/10. We have these left to check. Let's go back to the calculator and let's look at the graph. So we have these different spots here. Well, if we look at the far right, that one is between, so 1, 2, is between 2 and 3, yes? 2 and 3. So we can go back and look and see which one of these possible rational solutions is between 2 and 3. Well, turns out none of them are. 1/5, 1/2 is between 0 and 1. 3/2 is between 1 and 2. 2/5, 0 and 1. 3/5, 0 and 1. 4/5. So 12/5 is the only one above 1. It's actually above 2. Because 12/5 would be 2 into 5ths. So if one of them is going to work, especially all the way out there, it might be 12/5. Okay? And we could try it there. Now, twelve-fifths, unfortunately, does not work. And 12/5 on the other side doesn't work. So, well, that one's gone. So I would be looking at here in the middle. So the one between 0 and 1 where it crosses, it's really close to 1, yes? So let's look at these here. Out of all these here, which of these fractions is close to 1?
4, 5, 6,
4/5, yes, because 6/5 would be just greater than 1. So it gives us an idea of where to start.
1/2.
Yes. 4/5 is closer to 1. So let's start with 4/5. Now this seems like it would be tedious to do, but luckily for us, if we do this in the 30XS, this does make a lot of this process easier as we wait for this to load. So what we can do is 4/5 times 10, which is 8. So we come over here and do 8. Our next step would be to do negative 11 plus 8, which is negative 3. Yep. Four-fifths times negative 3. Well, this is not looking good so far, because negative 12/5 plus negative 42. Yep, no, there's a good chance. Yeah, and negative 4/5. All right, guys. All right. So 4/5 doesn't work. So let's try 3/5. And we can start the same process over again. We can say 3/5 times 10 is 6. Negative 11 plus 6, we can add negative 11 to it and get negative 5. And then we come over and do 3/5 times negative 5, which is, and if we add negative
42 plus negative 3 is 47.
negative 45. 3/5 times negative 45 is negative 27. Negative 27 plus 7 is negative 20. 3/5 times negative 20 is negative 12, and 12.
Hey, we got it. Look, guys, I was right the whole time. I told you it was 3 over 5. Like, you guys should have listened to the beginning. Oh.
Now it could be that negative or 3/5 works again, but most likely it's not. So we found the one on the positive side. We could try -3/5 and do this here again, because there's going to be a -1 also. Because -3/5, the first number is going to be -6. 5 plus -6 would give us -11. That one's not going to work. Yep. But one of the other things we can do is come over here, and there's ways to type this in, and we'll go over especially more of this on Monday. So -2/5 didn't work. Second, calculate value. We could try, say, -4/5. That doesn't work. Make value -3/5. And we're just using these values that we got here to try to find this value. You know what? Let's try -6/5. No. Yes. Yes. -3/2. I'm trying to remember which one of these is the other solution. 4, 5. Oh, wrong calculator. -4/5. Or it's too small. Too big. -3/5. -1/2. Yep, there it is. So we're just trying these different values, and -1/2 is our other one, because -1/2 times 10 is going to be -5. 5 plus -5 is going to be -10. -1/2 times -10 is going to give us 5. -40 plus 5 is -40. And -1/2 times -40 is going to be +20, giving us 0. Incidentally, those are the only two rational zeros out of this entire thing. The others, we're going to have to use the quadratic formula to solve. So to do that, we're going to go back and plug in our values of x. X and x squared. Minus 10x squared minus 10x minus 40 is equal to 0. And I talked about this in the video. Anytime we do have a greatest common factor here, it's going to be good to get rid of it. Since there is a greatest common factor of 10, we can divide this out and still get the same solution, but the numbers are going to work a little bit nicer, because 10x squared divided by 10 is x squared. Negative 10x divided by 10 is negative x. Negative 40 divided by 10 is going to be -4. Our value for A is 1, B is -1, C is -4. And when we plug this into the quadratic formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. We have -1 plus or minus the square root of -1 squared minus 4 times a times c all over 2a. All right, guys, let's focus in. -1 is going to be 1. 2 times 1 is 2. All right, guys. If we plug everything inside the square root in the calculator, we end up getting 17. So the other two solutions that we needed are this here. So it just tells us that we have this here, and x is equal to negative 1/2 and 3/5. Yes. So most of what we were covering, and we went into a little more detail with this, is we're really using the rational zeros in the graphing calculator to find solutions to simplify down. And whenever we don't get any, then we can use that rational solutions to solve for the rest. All right. Now we're going to do more of this in 4-6 with this here, these types of formulas and going through it. But if you start noticing, the graphing calculator is very helpful in getting these, because it's this one here. If I couldn't get at least 2 from the graphing calculator, we can solve with the quadratic formula. We can solve from there. But we need at least 2 to start with for a 4th degree. For the 5th degree, we need at least 3. We need 2 less than the degree solutions really for us to start with. And there's some that even the graphing calculator can't help us with, but there's other ways to it. Most of what we'll be covering is going to be that there. Questions on any of that there? So it's kind of a recap of the last 2. The only other thing that we have is this here, the irrational conjugates theorem. And really the big thing with that there is the square root of b is a solution. In a minute. Is a solution, then a minus the square root of b is a solution. So what that's saying is if we saw or told that 2 minus the square root of 5 is a solution for this here, it means that 2 plus the square root of 5 is a solution. If we have a radical, we need the positive and negative case. It could just be that x is equal to the square root of 17 and x is equal to negative square root of 17. If we have one radical solution, we have to have another. They always come in pairs of 2. We can't just have one. And that can sometimes be helpful, especially with the ACT or different tests. Well, they tell us that it has one irrational solution and one integer. Well, that doesn't work. It has to be in pairs of 2 with the irrationals. And luckily, I'm not going to worry too much with that there. Now, that has that there, but the homework is a worksheet I gave y'all. I think y'all got. You're just doing 1 through 8. So the first, I think, page is finding those rational zeros. So you're not solving 1 through 3. You're just finding plus or minus p over q. You're just listing all those out. 4, 5, 6, and 7. You're finding the solution. So I would graph it first and see if it lists the zeros. Like number 4, if you get 4 zeros by graphing it, 4 values of x that make it be 0, you're done. But that's it there. From there, guys, we have 4.6, and then we are finished with chapter 4. 4.6 is the last section.